Ladies and gentlemen, welcome to our Aero Talk today. Our event will begin in a short while. Before we proceed, we have a few reminders to all of you who will be with us from the beginning till the end of this program. First and foremost, this 2 hours program will be conducted live. Hence, we truly hope to get a good cooperation from each and one of you to not turn on mic and stay muted in order to avoid any interference to occur during the webinar. If there are any questions or remarks, please let us know in the chat box and we will assist you. Besides, at the end of the session, there will be a Q&A session. So you can post your questions during that session. Kindly watch your attitude and leave only positive questions or comments in the chat box. Second, please stay tuned with us until the last second. The attendance will be recorded throughout this live. And there will be a QR code displayed at the end of the session, which will lead you to the attendance Google form. We will also give the Google form link in the chat box. Hence, please make sure to stay tuned with us from the beginning until the end of this program. A very good evening to everyone. It is my pleasure to be the moderator for the talk today. I'm Sarveshni Yogindran. I would like to extend a warm welcome to all of you. We hope you will get an immense learning today as we have lined up an engaging talk titled Artificial Intelligence in Aerospace Engineering. Before we start, I would like to invite Saudara Farhan Al-Faizin to lead the prayers recitation. Please welcome.
بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين اللهم اجعلنا جمعنا هذا جمعا مرحوما وتفرقنا من بعده تفرقا معصوما ولا تجعل اللهم فينا ولا معنا شقيا ولا مطرودا ولا محروما ربنا عليك توكلنا وإليك أنبنا وإليك المصير اللهم طول أعمارنا وصحح أجسادنا وثبت إيماننا ووسع أرزاقنا وحسن أخلاقنا ونور قلوبنا برحمتك يا أرحم الراحمين اللهم اجعلنا من أهل الخير واجعلنا من أهل البركة واجعلنا من أهل المغفرة اللهم اجعلنا من أهل الجنة واجعلنا من أهل الفردوس أعلى برحمتك يا أرحم الراحمين اللهم اجعل مجلسنا هذا مجلسا مباركا لأصحابنا وأهلنا وجيراننا وضيوفنا برحمتك يا أرحم الراحمين ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Thank you, Saudara Farhan. It is hoped that our event will be success in His blessing. Without further ado, let me now introduce our honorable speaker for today. Mr. Ikrak bin Kamal is a researcher from the Aerospace Malaysian Innovation Center, which is currently focusing on automation and robotic programming. He received his bachelor degree in aircraft engineering and technology from UniKL Niat. He also completed his intern in Aerospace Malaysian Innovation Center. Mr. Ikrak Kamal actively participates in researches, and his main research interests are in programming and machine learning. He has introduced the application and potential of artificial intelligence in aerospace sector, including to multiple national universities and aerospace manufacturing companies basing in Malaysia. Now, I kindly request Mr. Ikrak to come and enlighten the students with his precious talk. Mr. Ikrak, now the floor is yours.
Hello. Can you guys hear me?
Yes, Mr. Ikrak.
Yeah, okay, thank you. First of all, thank you so much for inviting me to your events. I believe this is actually a very good event that has been held throughout the years. And I hope whatever that I'm sharing tonight will be very beneficial for you in the future and even now. So before, do you prefer me to go like straight away or any kind of introduction from myself? Do you need?
I think maybe you can give some introduction.
Okay. Okay. Just to add a bit more on what Miss Yogandaran, can I
Sarveshni again.
Okay, sorry. Okay, Miss Sarveshni.
Yeah.
So a part of being in a researcher in Aerospace Malaysia Innovation Center, I'm actually actively working on AI projects in AMIC. So AI in aerospace is actually a very new thing. AI itself is a very new thing. The whole technology has been developed in less than 50 years. So in a technological scale, that is actually very short, right? And AI itself has been implemented in various other industries like automotive, healthcare, F&B, and even law. But it's only back to like a decades ago that you finally managed to find a way through into aerospace industry itself. So in my presentation, or at least in our talk, I will try to give a bit of insight why AI has been quite difficult to be implemented in aerospace industry, and is it really true that we really need AI itself, right? As much as I would like to promote this technology to everyone or every single sectors that I'm actually presenting, we need to be pragmatic and realistic of the things that we have in our hand, right? Because AI is basically is just a tool, like any other technologies. How you use it, how you utilize it is up to you, right? So I think coming back to myself, so for the past couple of years, actually, I've been actively working on a project. I would say it's actually a deep learning project that involve more toward acoustic data signaling, right? But it involves more towards the optimizations of the automation process in industry utilizing deep learning architecture. I cannot talk too much about it since it's actually currently ongoing, and but I hope whatever that I presented in the slide will be enough for you guys to proceed if you actually have enough interest in artificial intelligence itself. Yeah. Okay. So I think I should continue with my slides then.
Yeah, sure.
Okay. All right. Let me just share my screen first.
Can you share your screen, Mr. Ikra?
Yes, I'm sharing my screen. Can you guys see my screen? Can you see it?
Yes.
Okay, great. Okay, since I believe your moderator has done explaining a bit of the structure of the talk, I wouldn't break much of the structure that has been said, but usually this is what I will do, especially to students. To be honest, this is the first time I presented to students, because most of my audience before are coming from professionals and also industry experts and whatnot. So I hope I'm not giving you guys too much of technicalities side of AI. I'm trying my best to touch a bit of fundamental conceptual of AI itself, so that we are clear enough on what AI really is, right? So if you look at the first slide that I prepared, there is you will see that 3 points that I'll try to explain to you guys, which are what is AI, the history of AI, and fact, effect, and progress. So the main reason why I chose these 3 points to present to you guys is to understand that, or at least to have a, I would say, the same understanding on what AI really is, so that we don't have any misconception of what AI is, and we don't have any kind of like, vague ideas of what AI really is. And then we're gonna look a bit into history of AI. This is just to make sure that we are not really being, I would say being lied by society or being lied by the technology that has been heavily advertised in TV. I mean, like you can see a lot of in TV right now, like almost every single phones will promote their phones to be the best because they have some kind of AI, right? Or almost every single stuff that has been sold, technological stuff that has been sold, will be promoted through the channels of having AI. So we are going to debunk that because we're going to get into the root of what AI really is. And the third point will be the factor affecting progress. Okay, this is important because when things get overhyped, there are potential for it to be, I would say, being in the winter, where suddenly no fund will be given, suddenly no interest will be continued from the previous researchers or scientists or even engineers. Right, so this is very important to make sure that we have a very clear indication or clear understanding or ideas what AI really is. And then probably we won't have any break since the Q&A session will be pushed to the end of the talk. And then we have AI for aerospace. This is where I will explain a bit the potential use cases of AI and where AI could actually fit into the aerospace sectors, not just engineering, but also in aviation sector itself. And also the companies that has made multiple moves in order to make sure that they are actually keep up to the current technologies and have that cutting edge to be better than their competitor. And then under the use cases statement is where I will be presenting a use case or actually a project that utilize AI in aerospace industry. This is actually could be very important to you guys, just in case you want to have or you want to implement some kind of AI in your FYP or your side projects. You could. So this will be presented in the slot, and then the last one will be how to start. Let's say, for example, you have interest in artificial intelligence, but you are in aerospace engineering. How do you want to make that transition? You're not computer science students. You're not software development student. So how can you, as a aerospace engineer, put yourself in the path of AI? So I will give you a bit of tips and advice here and there from what I've seen throughout the industry and also from what I've done for myself that is actually working. All right. And then we are going to straight with the Q&A session. If you guys have any opinion that you would like to suggest that might be lacking in this presentation, or you have any questions, please do. I don't mind, because to be honest, this should be a very good actually sharing session, right? Okay. So before I go into the content, this is actually the objective that we're trying to achieve for tonight. So the first one is to discuss background of AI itself. The second one will be to discuss the potential use cases. And the third one will be to discuss way forward for students. I think this is fairly simple objective that we can achieve for tonight. And I think those objectives will help you to have a clarified mindset on what can you actually gain for tonight's talk, right? Okay. So what is AI, right? Just to make sure, none of you guys are coming from computer science background? Do you have anyone? No? Okay. Never mind. Okay. So what is AI actually? I mean, if you ask around, pretty much, even inside the industry itself, for those who are actually not very aware of what AI is, most of them will think that AI is probably a robot or probably some kind of a Terminator kind of stuff that could potentially cause catastrophe to civilizations in the future. Well, the good thing is we are far from that. But the bad thing is we are actually far from that, which means that whatever progress that we have in the technological sense is not even a bit of what we have in our mind, right? So if you want to look more technical terms, it's just machine capabilities to imitate human-like behavior intelligence, especially in terms of making decisions and also solving problems, right? And if you look at the second statement, there is a system that adapts to circumstances as goal through learning and makes appropriate choice given perceptual limitations and finite computations. So you imagine you have a computer and you have a specific set of problems. Let's say, for example, you want it to play chess, but you don't want to make or you don't want to program every single moves that it has to make. So what you have to do is to make it learn from, you teach the computer to basically fight over 100 people, right? Multiple iterations, and throughout the experience, the computer will learn by itself and then probably be good at chess player. So, and AI is actually more than is actually almost everywhere, like even your home, even your smartphones, even your social medias, right? Even in the most prestigious Tesla, I would say, right? The most, I think that is the most highly evident engineering of artificial intelligence. Okay, like I said, it's in the phone, and particularly in your social media setting. Have you guys ever like try to fiddle around with social media and suddenly all your feeds has been bombarded with specific kind of advertisement or marketing stuff? So those kind of things actually algorithm developed by could be Facebook, YouTube, cater to, specifically to cater to your interests and needs, just to make sure whatever marketing or advertising that they are doing is being targeted to the right audience, right? So they learn all the data that is coming from you, from your behavior, on how long you scroll, how long you stay on one video and whatnot. And based on that data points, they will actually go back and show to you what you might be interested in, right? And on the heavily engineered side, I would say is you could actually look at Tesla. I know this is very like apparent, but Tesla actually utilizes what we call a neural network. I will go into that a bit later on. But and Tesla is actually utilizing what we call computer vision as well. Computer vision is basically intelligence based on visualization. So the Tesla cars actually have multiple different cameras that captured or stream of videos from the streets and make real-time decision whether on how can the car moves and where can the car go based on the current environment, right? So I hope for now we actually have a bit of understanding. Like it's not some kind of Terminator or robots. It's just algorithm working on a machine on specific kind of problems. And here comes with a probably a more lenient explanations of AI. We have narrow AI, general AI, super AI, and what we have now is actually it's just very narrow AI, which means an AI that could actually do one task and one task only. The knowledge that the AI gains cannot be transferable to any other task, and the limitations. I mean, like in that sense, it is nowhere close to human-like intelligence, right? So for those who are actually afraid that AI might take over human in workplace or might take over human industry and university, we are actually long way to go, like long way to go. And then we have like general AI. This is where it managed to imitate a bit more of human-like intelligence. And then we have super AI. This is at a point where it can actually, imitate and surpass human ability. So this is where, you will see that AI can actually do a lot of things that you can do, but in a better way. So this is the history of AI. AI actually started in around 1950s. To be exact, the term AI itself was coined in 1956 by John McCarthy. He was a scientist in Canada, a computer science scientist. So the first idea on how to imitate human intelligence is basically based on symbolic reasoning. Symbolic reasoning is basically trying to teach computer to understand symbols, right? So let's say, for example, instead of showing pictures or showing, I would say, numerical data, what the computer will need to do is just to know that, in a layman term, just to know that if human thinks that it's a tree, it is a tree. It's pretty hard for me to actually explain this thing, but that is the fundamentals of it. And the second phase is where the first AI winter hits. So this is what I meant by an overhyped technology. So AI was being overhyped for I believe it's a couple of times now. The first one being during the 1970s. This is where actually in the US they have what we call DARPA. DARPA is supposed to be giving a lot of funds and ideas to the researchers and whatnot, but the researchers technically failed to produce a very useful use case, right? So it's all very idealistic, but none of it is pragmatic and realistic, right? And then throughout the 1980s is where they have a bit of collaboration with Japan's, and also there are also revolution in terms of more computational power can be developed through computer and whatnot. So this is where they develop the expert system. Expert system is basically trying to teach a computer to imitate an expert in something. Let's say, for example, you have an expert in maneuvering aircraft. So every single decision that that person make will be copied directly to a computer. And let's say, for example, the computer will go through the same situation the pilot made, went through. It will make the same decision. The problem with the expert system is it is very rigid, and it is only use case specific. It's very limited, which leads to the second AI winter. Right, the second AI winter is caused by the failure of expert system. It's overly promised, overly hyped, and this is where the first market crash is economic crash happens, which contribute to even worse condition of artificial intelligence itself. And then we start to go into the 2000s, 1995. This is where the peak of, I wouldn't say the peak of AI, but the start of something new in AI itself. This is where intelligent agents start to be introduced. Intelligent agents is the applications of machine learning and deep learning. If you guys have heard about that terms before, this is where scientists started to approach things from a statistical standpoint, from mathematics standpoint, and understand that decision making can be made through mathematics, right? So from there, now all algorithm has been developed and working very well in various industries. And I should include there, but only up to like 2007, it is actively being introduced in aerospace industry, right? Okay. So these are the factors that actually impedes the development and the progression of AI itself. So the first one being computing power. At that time, we know that the computation power is very limited, right? What you have now in your phone could be like physically probably 100 times bigger back then. They need probably a lab just to have a computation power of your phone, probably even bigger. And then the second one is data availability. So from the, we know that data comes from sensory, right? You know that data comes from people giving input to something. At that time, we don't have sensors. We don't have any kind of people involved in producing enough data on specific use cases. So you cannot basically teach something without any information, right? Like how would a baby grow is based on trial and errors. So that is the same case with AI itself. And the third one would be algorithm development. This is where you see that multiple different approach has been made by creating expert system, by creating symbolic reasoning and whatnot, and those doesn't doesn't give you the result that you actually wanted, and hence leads to multiple AI winters of. Okay. So this is where I would delve a bit into the layers of AI. So based on our definition just now, AI, artificial intelligence, is just a program, right? It's a program that are supposed to be able to think and act like human being. But how we are supposed to do that? What is the ways or algorithm that can be used in order for us to achieve that goals? So those two things are one of the most prominent, or at least the most popular in AI field, which are machine learning to enable computer to perform tasks without explicit programming. I believe you guys have a bit of you know skills and knowledge in programming, at least Python. So in Python, you understand that certain things you need to code based on, if in order for the computer to work, you need to code the instruction for the computer to follow. That is what we call explicit programming, step-by-step programming, right? But machine learning does it without the need of explicit programming. Meaning, what you need to do is just to teach the AI program that you've made, and then it can make the decision without you having to teach it manually. And deep learning is actually a subset of machine learning, and deep learning is actually inspired by human brain which are coming from the neurons of your brain and how it's connected to one another. Great. Right. Sorry if I'm getting a bit too technical, but this is the AI framework. Let's say, for example, if you were to implement an AI, basically you will have two things that you will need, which is you can see there is a training phase, and then the bottom part is the testing phase. And then on the training side is where you require a lot of data. Okay, let's say, for example, you are trying to detect or classify the cats images that you found online. So what you will need is a lot of pictures of cats, right? From multiple different angles and various, species or even types. And then you put those things inside your machine learning algorithm. And once it is trained, whenever you put a new data, it could be a dog, it could be a cat. And based on the trained model, it will classify whether it is actually a cat or dog. So this is actually the framework that has been used for like years. It's not much of a different until now. It's just that the architecture of the algorithm is getting a bit more, advanced, right? So three things you will need in order for you to implement machine learning. The first one will be the objective. What is it that you're trying to do? What is it that you're trying to classify? What is it that you're trying to predict? Second one is you need a relevant data. Do you have relevant data? Can you generate relevant data? And the third one is the suitable machine learning model. So we have multiple, not even multiple, probably thousands up to now, machine learning models actually available that has been researched, that has been developed. And for you, if you want to start developing, you need to understand at least the fundamentals of it so that you can try to utilize one of them. Right. So this is the fundamental concept from what from what I've explained just now. So let's say, for example, here we're trying to predict the strength of the composite structure, right? So in here, you know that I have four datas in regards of the composite layers number and also the strength of the composite structure itself. So one layer, you have probably 10 Newton of strength. Second, you add up another layer, the strength becomes 12 Newton. You add up another layer, becomes 13.7, fourth layer, and become 14.9. So the task now is, let's say, for example, I have trained my model with the 4 points there, and my task or my objective is to figure out what is the strength of the composite structure at the fifth layer, right? So using a basic linear equation like this, y max plus c, if we plot it into a graph, you can see that, okay, this is standard plotting. Let's say you put the third layers there. So, and then like you wanted to predict what will be the next layer. So in machine learning algorithm, we are going to utilize what we call a mean square error. Right, mean square error is just basically average error throughout your equation. How much error your equations are making in predicting something, right? So the aim of any machine learning algorithm is just to reduce that mean square error in order for it to find the best fit line, right? So the less mean square error that it has, the more accurate your model will be. Okay. So, and what it will do is, in order for it to learn, right, after every iterations of layers, it will keep on updating your gradient and your C, which is your y-intercept here, which in turn will affect your graph plotted, right? So after multiple data centers have been input, you can actually predict where it will be when you put in the fifth layer. Let's say, for example, here I've plotted 4 points, and I want to predict the fifth points. We can safely say that the fifth point will probably fall somewhere around there, which is 60.1 Newton, right? So this is actually the fundamental concept of AI. If you look at it, this is not Terminator kind of technology. This is just mathematics, right? So once you have that kind of understanding, you will realize that, okay, it's not really complicated to be deployed or implemented. It's just that you really need to like a bit of mathematics here, right? Okay. So let's say for example, this is where I explain a bit about the explicit programming just now. The difference between explicit programming, which are your standard programming method, and the typical machine learning is just the structure between where you put your data and rules, right? So for explicit programming, you yourself will specifically state what is the rules that your computer need to follow, and you put in the data whether can it actually fit in into the rules that you have set up, right? Once it fit in, it can provide you the answer that you want. But unlike that, machine learning works inversely, which you give it a lot of data and you give it a lot of answer based on that data, and it will try to make the rules for you so that any kind of new data that you're putting in, you will have the better answer of it. Yeah. And this is basically what I mean by that. So in Python, let's say for example, you're trying to decide whether this thing is actually an aircraft or Airbus Beluga, right? So you decide the first one is that is your data. So the wingspan is going to be about 45 meters. The weight is going to be about 86 tons. Fuel capacity is around 23,000 liters. So your rules will be if, let's say, for example, the wingspan is a certain amount, if the weight is a certain amount, if the fuel capacity is a certain amount, this is actually aircraft beluga. If other than that, it is not considered aircraft beluga. And the best thing about explicit programming is you are able to get 100% accuracy based on the rules that you have set. Unlike machine learning, it can only predict. It can never get to 100% accuracy. It's compared to your I would say explicit programming. But what is the con of utilizing explicit programming is you need to realize that you need to know all the rules that associated to certain subjects. Let's say, for example, in this case, you need to know every single thing about probably a bit of major things about aircraft beluga that can actually help the program identify it as aircraft beluga, right? But let's say, for example, I have probably damaged aircraft beluga and the wingspan is no longer 45. So up to that point, it'll be pretty difficult for you guys to actually decide whether that is aircraft beluga. Till what point you can actually consider something as the subject, right? If let's say, for example, the aircraft is damaged, to what point is it actually, it can be associated with aircraft beluga itself. And then another limitation with this is it requires a lot of extensive feature engineering. Let's say, for example, I give you a picture of aircraft beluga. It'd be very difficult for you to actually decide, right? Because the rules that you have made is just simply based on numerical data and not by pixels coming from the aircraft beluga itself. Okay, so far so good. Am I going too fast or too slow? Am I boring you? Can someone respond?
No. It's just a bit too technical, but then we can understand.
Okay, sorry about that. Okay, never mind. After this, we're just going to be delving a bit more into aerospace sector itself, right? Okay. All right. Okay. The next one. Why AI for aerospace? This is the big question. Can AI really be implemented in aerospace sector itself? And do we really need AI in aerospace sector? Right. So those are actually the question that you need to ask whenever you implement new technology, not just AI. Every single technology that you encounter later on in your life, you will need to ask those questions. If you are going to academics, even if you are going to engineering, you will came across multiple different technologies, and some might be suitable for your use cases and some might not, even though you are biased and you like it so much, right? So you need to be realistic here. But before that, I will just explain that why AI could be actually making an impact in aerospace industry is the first one is the data available. As you can see throughout the aerospace industry throughout globally, you can see like a lot of digitization is happening. So a lot of new sensors has been installed, a lot of things has been digitalized, from aviation stuff, from your ticketing, from your probably even meals inside aircraft itself when you're flying. And then from the manufacturing standpoint, a lot of optimization of process requires a lot of data. So there's a lot of data is made available to be utilized there. And like a lot of people are saying, data is basically the new electricity, right? You can actually survive a lot based on data. You can make predictions, you can make classifications. Up to a certain point, you can even predict death, like how you predict COVID-19 cases with data that is available, right? Um, Secondly, it would be high accuracy multi-objective optimization framework. So in layman term, what does this mean is in aerospace industry, you have a lot of objective that you need to achieve. And every single objective that you need to achieve is very rigid, very strict, right? Let's say, for example, you try to assemble an aircraft parts. The tolerances of aircraft parts could be up to 125 micron or 0.125 mm. So that's a very strict objective that you need to achieve. And probably you probably have multiple conflicting objectives, right? With the same strictness. So how can you do that? Human being can only do so much. So this is where you probably can utilize a machine learning optimization process, machine learning algorithm to optimize your process and whatnot. And then the third one would be the advancement of sensing technologies, data storage and transfer. This is where the one I see just now. We have a lot of different kind of sensors. Even in your phone, even whoever is using iPhone now, you can figure out that there's actually LiDAR in your phone, right? So up to that point, we know that sensors is everywhere. And with the fact that when sensors are very everywhere, we know that a lot more accurate data can be collected. So the higher the accuracy of your data, the higher the accuracy of your machine learning model or your AI, right? And then the fourth would be, this will be my weakest argument, will be the RF 4.0. We know that throughout the globe in various industry, people are just trying to, catch the hype train to build their system revolving RF 4.0. Not to say that it is overhyped, but some industry do need it, right? Some industry need it. But with aerospace actually involving a lot of high tech stuff, right? I would say among all other industry, even automotive industry, even healthcare, banking, and whatnot, aerospace is actually the highest tech industry available compared to the other industry. So we are actually the pioneer of most technologies that are actually being used in mass. So we should try to actually implement the AI system inside the aerospace sector in a more rigorous manner, right? Okay, so this is actually the roadmap. What has been planned for the next, I would say, 14 years up to 2035. Yes, and this is actually being planned by EASA. If you guys have any idea what EASA is actually standardized for human aviations and flight training, one of it. Right. So they concluded that the implementations of machine learning or AI could be differentiated under three different phases, which are the first one, exploration and first guidance development. The second one is framework consolidations, and the third one is pushing barriers. So we are actually right on the spot where we're still trying to develop. EASA can be recognized globally. So if we were to start in Malaysia, or as a students, if you were to start, this is actually the perfect time for you to start, right? Because everyone in the whole globe is still in exploring mode, right? They're still developing on how can we navigate this environment to implement AI itself. So this is actually expected to go up to 2034, where they should be able to produce some kind of usable guidance for human being. But just take note, EASA main focus is actually inside the cockpit, meaning to help pilots itself, right? How can they optimize pilots? How can they optimize autopilot system? And how can actually they help pilot to fly planes over long flight time? So there are three levels there: human assistant, human collaboration, and autonomous machines. each levels subsequently become more independent from human itself. And on the second framework, which is expected to start on 2024 to 2028, this is where we consolidate those framework. You have done the exploration parts, and then now you consolidate it and try to make a template so that everyone can follow you, right? And after that, it's just fly. Once you are able to integrate AI, and once you have a very strong template that you can actually use, you can potentially see AI everywhere. So, as a researcher, I would actually encourage you guys to actually delve a bit into this. Probably in aerospace engineering, you're not really focusing on this side, but you can actually take into account of this thing as well, because we are actually moving globally towards this thing. And yeah, okay. And this is actually where we implement AI most of the time. The first one being what is done by ESA, which is the optimized flight performance. Second one being generative design, who actually likes to use CATIA over here. So generative design is actually good. I see a lot of people raising hands. So generative design can be used with CATIA actually, where you have multiple parameters that can be set up, and then the algorithm will try to generate design for you, right? And then we have efficient supply chain management. This is more toward logistics sides of it. And we have quality control and NDT. This is specifically for MRO. And the last two will be training for AR, VR. Anyone here has experience with AR or VR? You know, with the goggles and stuff, and then you see the virtual reality. Okay. So this is actually being developed with Airbus, with Boeing itself, right? So this is interesting. One of the areas you want to join. And then last one is predictive maintenance. I would say this is the most boring part, but this is the most realistic implementation of AI in the aerospace industry. Yeah. Okay. So if you're not convinced enough, those are actually the companies that have started to implement AI. So those are actually very big companies, aerospace companies. You can take note. Probably you want to apply to those companies after you graduate and whatnot, right? So those companies are actually started their movement probably around 2011 to 2012. They start to acquire new startups. They started to acquire smaller companies that is heavily involved with AI itself. And even Boeing itself invested 32 million on Spark Cognition. So Spark Cognition is actually AI startups or AI small companies that develop computer vision system for aircraft, right? So those companies is actually grouped together based on these factors. I know you see a lot of boring numbers here, but it's basically just how heavily they are involved, like with the patterns, with how many people they are acquiring, the talents that involved with AI and whatnot. So yeah, take note. Those are actually the companies that you might want to apply to. We have probably I think all of those have not HQ, but actually have a headquarter here in HQ basically in Malaysia. For the acceptance of, I believe Northrop Grumman is no longer in Malaysia, but other than that, it's still in Malaysia. So you guys can look it up. Yep. Okay, this is the use case example. Right. Bear with me. It's a bit boring still, but let's say, for example, you have an idea on, like, you want to implement AI for your FYP, right? You want to try something new, you can take an idea from this thing, probably try to implement in drones and whatnot. But basically what those scientists or those researchers are doing is just trying to predict defects, right? So if I'm pretty sure that you guys are well aware of the fact that aircraft go through multiple different maintenance, A check, B check, C check, D checks. It is heavily maintained throughout your lifetime. But even so, there are still certain anomaly or still certain defects that cannot be detected, right? So this is what the guys are trying to do, based on the data that they are trying to they managed to collect. They are trying to detect faulty that comes from degradations, right? and specifically at the aircraft cooling system. So they collect data from the aircraft cooling system based on their vibrations and the sound that is produced. And over the lifetime of the aircraft, they generate what we call a predictive maintenance, right? So this is good because the A check, B check, C check, D check cannot cater to every single kind of problems and defects. But this system managed to get to a point where it can detect up to 0.2% of occurrence, meaning very low, right? And the second one is actually done by university in Singapore, right? So just a bit of segue. Even though Singapore is not that far from us, but Singapore, compared to Malaysia, Singapore is actually the number one country in innovation, even beating US, even beating Israel, even beating German, even beating China, right? Not to say that all Malaysian talents should go there, but if you have the opportunity and want to heavily involved in a very R&D level, design, implementations of aircraft, Singapore is one of the best way for you to start your career. Because to be realistic, Malaysia aerospace industry involved more in manufacturing, involved more in assembly, and also optimization process of composite fabrication, right? So we are not actually, to be honest, in Malaysia, we don't really have any kind of companies that is heavily involved with designing of aircraft. We don't have that. What we have, we receive from probably France, Airbus, or US, Boeing, specific things that need to be done, and they actually let us do it based on what they design. But we don't have any from the scratch kind of aerospace implementations in Malaysia, right? So we are actually, the higher we have is second tier. That's about it. We don't have any first tier productions in Malaysia. So what is done by the University of Singapore is using image to detect defects on aircraft skin, right? So they are using what we call convolutional neural network. Convolutional neural network is a part of deep learning models of AI. Yeah. So what they have managed to do is to detect any kind of visible damage that could be appearing on your aircraft skin, right? Just by using a simple 388 by 5184 resolution of pictures. So and yeah, the accuracy is pretty great. This paper is actually, you can find it online. The accuracy is pretty great, and I think if you have the data, you can just duplicate it and try it on your own, right? So okay, this is actually, I believe this is going to be useful for you guys on how to start with your AI journey. Let's say, for example, you have certain ideas or you already know what AI could potentially be used for, but you don't know where to start, right? But I believe every single of you guys have a bit of understanding of programming, a bit of understanding of mathematics, statistics, calculus, or even algebra. If you have that, you are more than ready to go. You don't really need computer science, no matter how many people tell you that you need it, you don't. Because AI is just a subset of computer science, right? And what I'm showing here is from the right side is what are the software that has already been developed that you can use. This is readily available online. Probably one of it is, no, I'm sorry, only one of it, I believe, is orange. You have to pay for it. Other than that is actually free. So those software, those algorithm has been made. You just need to fit in the data that you have, and then the decision or classification can already be done for you. And you go a bit deeper than that, you have what we call Matlab. So Matlab, I think a lot of people are actually very familiar with Matlab. Matlab has their own libraries and modules for artificial intelligence, right? So you can just use that without having core, programming skills. And another one is NI, National Instrument. Same case as Matlab, developed for you guys, but ready to plug and play. And the last one would be just code it from scratch. You know Python, you know C++, you know R. You can just start from scratch. You just need to figure out what needs to be done. All right. So these are the things that you need basically to become a data scientist or machine learning engineers or AI engineers or whatnot. In part, you just need a bit of programming. You just need a bit of okay, at least some kind of interest in mathematics. Not to say that you have to have a very good grasp of mathematics, but having a good understanding of mathematics can actually help you to understand the inner working of the algorithm itself. So if you are going into the academia, you will need to go through the mathematics even more because you will be handling them directly. But if you're not, if you are just going to implement it, you don't need to, but you just have to understand what is going to be, utilized by using mathematics. And the use case. So this is where you could actually probably propose to your professors or lecturers the thing that you wanted to do through your FYP, right? So, and even I would suggest if you want, you can just collaborate with a computer science department, right? To develop your own FYP, because I believe for every single fresh graduates, even though you might think that your FYP is not important, but as an employer, FYP is actually one of the things that we look, right? Not just your grades, your FYP. If you are very good in handling your FYP, and if let's say, for example, we question you every single thing about your FYP and you manage to answer it well, you will be good, right? So might as well, once the fact that you are actually in this talk tonight, you know what is important, try to develop it. And it could be a plus point or advantage for you later on over other candidates, right? So you're doing something that is actually quite extraordinary, I would say, something different from other people, not just a typical aerospace engineering FYP. This is something new. This is a collaboration between a bit of computer science and also aerospace use case. But if you want to start right now, if you're not a final year student, you can go into Kaggle. Kaggle is just basically a machine learning website, right? You can develop your repertoire there. You can just start your account. It's free. A lot of use cases made available to you. Even COVID-19, even Malaysian COVID-19 cases data is available there. You just need to play around. And the last but not least is GitHub. This is a bit heavy, but if you really serious about getting, continuing your career that is related to AI, GitHub is one of the most important thing that you need to have, right? You need to develop your, I would say, portfolio in GitHub. And in GitHub also, you can actually collaborate with other people around the globe in multiple different discipline and also sectors of AI. Right. Okay. Actually, that is for now. Um, so I'm open to any kind of question. I know this is a bit technical. Again, I apologize because this is actually the first time I explain it to students. So if you guys have any questions, I'll try to answer it the best I could. And if you are not, if you don't want to ask any question, you can just contact me at my email there, right? If you're shy to ask now, you can just ask later. I'll try to answer it the best I could or the fast as soon as possible. Yeah. Thank you. I think
Thank you very much for that fruitful and informative talk, Mr. Ikra. Now it's time for Q&A session. Please don't be hesitant. I would like yourself to unmute and introduce yourself before you ask your question. You can also post your questions in the chat box, either in YouTube or in Zoom.
I'm just gonna stop sharing my screen now, I think. Okay.
Hello.
Yeah, hello.
All right. Muhammad Hazim bin Muhammad Neda, and I'm
Okay.
from semester 1, Department of Aerospace. I have a question. Is it true that if we go into the website, they have some website need to approve either we a robot or a human? So we choose. We need to choose the picture. Is it true? For example, like traffic light or cars. Is it true that we contribute to the machine learning?
Okay. I cannot say for all companies. Sorry, Mr. Azim. Yeah.
Okay,
So I cannot say for all companies, but multiple different companies has been doing that for so long actually. Like whatever that you do online, let's say for example, they ask you to detect the picture of traffic lights in order to verify that you're a human. They're actually gathering data from you to understand that the picture contains a traffic light. So yeah, it's true.
Okay, thank you.
Yeah, no problem.
Mr. Ikrak, we have a question in the chat box from Ray.
Mhm.
Do we need to retake our engineering license if we work overseas?
Okay. As much based on my informations that I have in regards with UPM, UPM is actually registered under IEM, if I'm not mistaken, right? Right. So if you are actually registered under IEM, go. Yeah. So if you are taking engineering license from UPM, no, you don't have to. Right.
All right, Mr. Clark, I have a question. My name
Yeah.
is Hanan Shamsuddin. Okay.
Yeah.
All right. So as we know, AI, it defined as a technology that tries to mimic human capability, so mimic human brain.
Mm-hmm.
So, of course, I think you have been bombarded by these questions over and over and over about unemployment. Maybe until one extent that when AI can reach human capabilities,
Mm-hmm.
is there? I mean, based on your opinion, based on your experience, based on your knowledge yourself, do you think that is going to happen unemployment if the AI can reach the human capabilities?
Okay, I break down that question into two parts on what is actually happening now and what is actually will probably happen if the trajectory of AI technologies is the same, right? Probably exponentially growing, right? So nowadays, even like in current manufacturing, companies like Spirit or SAE, right? They started to look into this what we call ethical AI. So they need to actually provide a good policy in implementing any kind of technology, this also including AI. So when a lot of repetitive tasks has been replaced by robots, by AI, right, there must be some kind of compensation need to be made to the worker, right? But from what I see, actually, even though you are implementing a lot of new technologies, usually a new position will arise. Let's say, for example, I implement an AI system to take over the MRO side, but somebody needs to take care of the AI side. Still, somebody needs still need to have a look on the AI system, whether it is working correctly, whether it is working up to the standard that I've set. Somebody still need to do that. Up to that level, we still need to do it. So, in to answer your question, on the first case, or at least now, we are actually nowhere near that. And I mean, like, I understand the concern that most companies have, but from my point of view, I would say that it is something that need to be integrated, not replaced, right? Like all technologies, AI need to be integrated, not replaced. Probably at a certain point where AI could be, the turning point of productivity of humanities. Like probably you don't even have to go to work. Basically, AI can just do work for you. That should be answered in a more, I would say, philosophically manner, right? If you're taking up to that extreme points, probably government need to take some kind of initiative, right? On what can we do to actually contain this technology, and because eventually AI is still a machine. The ethics in AI is implemented by human being. So collectively, if humans are good, AI should be good. Optimistically speaking. Yeah.
Okay, thank you, Mr. Clark.
So I have one question from Raja Izzuddin. Right. So what is the recent research or innovation in Malaysia regarding AI in Malaysia? Oh, okay. So the most recent research was done back in, I would say this is the most recent because this has been proven back in 2018 It was more toward optimizations of factory path. So in a factory, right, you have what we call a FIFO system, first in, first out, right? Like for example, you receive a good, you have to make sure that good need to be processed and then be exported out based on its sequence lah, basically. So what has been done in a company like UPECA or what we call T7 Aero is they're trying to optimize the system by eliminating the process that not need to be done in order to make sure that the FIFO system remain intact. So that is one of the recent and provable use case that is implemented in AI. So it is very lame, to be honest, but it works. Yeah. And actually, right now, for the time being, as we are talking, we, especially in NAMIC, we are actually heavily involved in predictive maintenance. Just trying to do aircraft assembling machines and aircraft fabrication machines. Most of that, we're trying to implement some kind of preventive maintenance process into it. Yeah. I would say if you look into other industry like automotive, maybe you will find something far more appealing, like probably driverless car, automotive. A lot of companies have been doing that. Even in Malaysia, we have 2 startups in Cyberjaya that is actually actively doing it. Oh yeah, I forgot. There's actually one thing that might be a bit interesting, which are training for pilots. Right now, must have a bit of one sector doing this where they have a simulator, right, that caters to the environment, the real life environment, and help pilots to actually train in a more realistic manner. Yeah.
We have a question, Mr. Ikra. From your point of view and out of experience, what is the best position of field and aerospace engineering student do you think should pursue for their career?
Okay, if we were to pick Malaysia, right? So like I stated before, Malaysia is not heavily involved in designing. Malaysia is not heavily involved in, tier 1 fabrications or manufacturing. Malaysia is heavily involved in tier 2. What I mean by tier 1, tier 2, tier 3 is how the part is being assembled, right? So to answer your question, you could be a technical services engineer. Yeah, there's one of it. You could be an aircraft maintenance engineer, another point, that essentially have the highest prospect. Or you could be a research engineer, like me. I'm not saying that this is the best path, no, but based on your inclinations or what is the thing that you're interested in, yeah. But I would say those 3 things have at least probably the highest potential of, for you to pursue for your career, right?
I have another question.
Yeah, sure.
Talking about ethics, just now you were talking about ethics. As we know, when there's technology, so human dependence on technology will be higher and higher. They rely on the technology. So when there is no interaction between human, or maybe our interaction is just between robots and on computers, how does it how do we ensure that our humanity values are still there, even though we are relying on the technology itself?
Okay, that's a deep question there. I think
I'm not trying to be pessimistic. It's just it's just a random question, I guess.
Yeah, I understand your concern. Thank you for the question. I think that's a valid question. Actually, as technology grows, we will be relying a lot more on technology. Probably at some point, we will not even trust ourselves compared to what the technology could provide. But humans still have instinct. Humans still have basic emotions. Those are the things that you cannot eradicate. I believe not in the nearest time. Like you cannot really remove the self part of yourself. You still have your character. You still have that, empathy, sympathy, and whatnot towards other thing and objectively towards something. So even if you evolve more towards robots, you still have feelings. You cannot remove it as a whole. So again, the answer is how you integrate the technology in your life. It could be potentially good for you. It could be also something bad for you. And if you manage to control it, if you manage to use it in the right manner, then I think it shouldn't be any problem at all.
Can I ask one more question regarding the other question?
Yeah, sure.
Yeah, you said that regarding Malaysia, the best, or yeah, one of the best things you can reach to is a technical server and technical service engineer, right?
Sorry, I couldn't hear you breaking.
And let me. Is it better now?
Yes, definitely.
Yeah. Sorry, I was saying you said regarding Malaysia, the best position you can be in is a technical service engineer. Am I right?
One of it, yeah.
Yeah, one of them. How about outside Malaysia? Are there higher positions that you can be in if you work outside Malaysia?
Yes. Actually, if you manage to go out even to Singapore, you can actually involve more into mechanical parts or designing parts of the aircraft. I would say design engineer could still be a very good option for you, right?
What? Sorry again.
Sorry.
A what engineer?
Design engineer.
A design engineer.
Yeah, a design engineer, or probably what we call system engineer. Yes, you could actually potentially goes into that. But if you manage to probably somehow end up in Toulouse, France, in Airbus itself, right? There's like, I believe, vast amount of position will be made available for you. Almost every single part of the aircraft is made from scratch there. So yeah, it's just that my main point just now, just to make sure that we all understand where Malaysia priority is for the time being, because we don't have much resources like Airbus. We don't have much resources like Boeing. So this is our focus in, which is in composite manufacturing and also assembly.
All right, thank you very much.
No problem.
Mr. Ikrak, I have a question.
Yes.
Okay, since many universities in Malaysia do not offer aerospace engineering and related to aerospace, so how did you ended up in artificial intelligence and aerospace engineering, and how did you ended up becoming a research engineer?
Okay, that's actually a very good question. Actually, this AI topics have been dwelling in back of my mind during my students' time, right? Even when I'm not doing any kind of side projects in AI at the time. But by the time I managed to get my internship position in my current company, it was at that moment I managed to develop a few side cases, I would say. And somehow that kind of pivoted the company to realizing that AI is kind of important. Yeah. So that is, and after that, it's just like added up from there. I managed to do something that I like, and yeah, it's cool. So that I would say if you this is not just applicable to AI. If you have some interest even outside of aerospace engineering itself, I would say just develop a very small use case that you can work on, right? Could be drones, it could be automation system. You just need to start from now. Start really small, and probably who knows where you end up. This, because employer will just need to find a proof. Like you could claim that you have been dwelling with a lot of different kind of system and whatnot, but eventually what the employer will look into is that have you really done it, and if you have done it, how did you do it, and how better the system gets as you go through life, things like that. So yeah, that is how I ended up as a research engineer actually.
Thank you, Mr. Ikrak.
No problem.
Mr. Ikrak, I have a question.
Yes.
My name is Simran Jin.
Mm-hmm.
I'm in the year 1, SEM 1 as well.
Mm-hmm.
My question is, since the trend today of aircraft manufacturing is going to to more composite material instead of pure metals, how can we deal with the the composite material used after the aircraft is retired?
You mean how can we wait, let me rephrase that question. You mean how can we better utilize, or how can we better dispose retired aircraft that utilize composite structure, is it?
Yes, since we can't salvage the composite materials.
That is actually very true. That is a good question actually. Okay, I would just like point out that this is based on how Airbus did it, right? So for composite part, especially carbon fiber, it is very hard for you to at least recycle it. So what they do is, to be honest, the solution that they make is not the best solution. So far, as far as I know, based on my experience in this field, the best way they can do is like trying to transit from utilizing what we call. So inside composite, you have multiple different kind of fabrication methods, right? You have layups, you have autoclave, you have RTM. So what they're trying to do is to try integrate usability products within that process. So when the aircraft disintegrate later on, the product will help to disintegrate the aircraft, but still you will have a lot of undisposed waste left on Earth. And if you Google enough, you can actually see there's like a lot of unused aircraft that's just like parked sideways, because they haven't managed to utilize this kind of problem, solve this kind of problem up to the core yet. Probably you could start a company and do that. Who knows? One time. Yeah.
Thank you for your response, Mr. Iqbal.
No problem.
Mr. Iqbal.
Who we're talking to?
Hanan again.
Oh yeah, okay, sorry. Yes.
Okay, having said that, just now, aerospace waste is you said it's quite a big problem that we are facing right now. So how does AI plays a role in reducing, maybe optimizing the manufacturing and stuff like that? Do you know any chance of UI that can be implemented so that it can reduce the wastage of the aerospace? Yes.
You can look at this from the standpoint of the fabrication itself, right? Any kind of fabrication methods will have some tests need to be done. For the most common one will be tensile strength and whatnot. So based on that data, you can actually utilize the best ratio of components or materials that need to be utilized. But I would say this is a very generic statement, but just to add up for that, we are actually transitioning not just composite, we're transitioning into additive manufacturing, right? So in additive manufacturing is, I would say, probably one of the solution to this kind of things, because additive manufacturing introduce a lot of recyclable materials, even though it is composite. Yeah, and I think AI will come into place in just optimizing the material used when fabricating something. That's about it. Yeah. Is it clear though?
It's getting there.
Yeah, because obviously I cannot provide you the real framework, but that is where I see the potential of the AI in this use case.
All right.
Mr. Ikram, I have a question now.
Yeah.
Okay, you said FYP projects are very important, and you will see as an employer, FYP projects are very important if you see as an employer. Why do you say so? Like, how does it contribute to our employment?
Not to downgrade any students here, but okay, if you study, you can get good grades. Like if you just need to put in the effort, study, go to the exam, get good grades. But actually the FYP is where we differentiate you from other students, right? So how detailed can you explain on your FYP, or how interesting your FYP is, or how actually novel the idea of your FYP is one of the biggest factor why I believe in any industry will take you, right? So assuming you have 2 4 flat students, one FYP is okay, probably by textbook. Not to say textbook is bad, but one FYP is, is very original, I would say, and very critical or important. There could be the factors that we are taking into account and why we should ask you. Plus, when you're working on FYP, there are certain skills that you will need to develop, right? So if let's say, for example, you want to implement AI in aerospace, you will need programming, no doubt. So we know if you are able to do that, you're also good at programming and other skills related to your FYP projects. So that is actually a proof that you can provide us as an employer that to to convince us that okay, this thing, it's not just on paper, it's proven. Yeah.
Okay, thank you, Mr. Ikral.
No problem.
Hello, Mr. Ikral. My name is Alisa. I want to ask something.
Yes.
How do you know?
Sorry?
Wait. How do you know which one? Wait. It's my friend's question. How do you test the intelligence of a machine? Like how to know which is better? Which one is better?
Okay. Okay. So for every single machine learning models or deep learning algorithm that you try to deploy, right? So you will need to go through a test. There's a lot of tests. One of it we call Z1 test. We call statistical tests. What the test is doing is basically trying to compare the accuracy of your models, right? Based on the data that you have. Okay, it will compare. Let's say, for example, you're trying to actually classify the images of cats, right? You will try to find the data that you have labeled as a cats and find the similarity between those two data, and try to detect how similar it is. So based on that similarity, it will, let you know whether your system is working well or not. That is one of the way. There's actually multiple other ways to do it. That's one of the way to do it. Is based on based on the data that you have as well. And not just that, let's say, for example, you're taking data from the internet as well, right? You can actually make what we call statistical judgment. Let's say, for example, out of 100 data that you have, how many is accurately predicted? So, I mean, you can do that as well if your data is small enough. Yeah.
Okay, thank you, Mr. Ikral.
Right, no problem.
Right, Mr. Crow, I have received a question from YouTube Live. Okay, it stated that, just read the question. Hi, my name is Mikdad. So may I know what are the difference between AI that has been applied on a, let's say, a commercial or a general aircraft company like, Gulfstream, Boeing, Airbus, compared to specifically as a defense aircraft or fighter aircraft or military aircraft? So how does it difference from, just a commercial airlines to a defense technology?
Okay. Thank you for the questions. I would say the main or the fundamental difference is just in terms of the use cases, right? Probably in terms of military, even RMAF, Malaysia itself, it's more towards combat. So, but the same, I'm not saying the same system, but the fundamental concept is still the same. You still need to teach the machine how to do it, right? It's just that on commercial ones, the use cases are far more, non-combat kind of thing, because like what I was explained, it's more towards utilization, how to improve the overall flights experience, how to improve the longevity of the flights, the plane, and how to improve the training of the pilots and whatnot. Not to say that it won't have any kind of overlapping, but the main priorities for aircraft combat system would be for combats. That is the fundamental difference. But the system is fundamentally still the same. It's still something that you need to develop and teach. Yeah.
I got one more question. I'm sorry.
Yes.
Yeah, what's the difference between a person studying aerospace engineering and aeronautical engineering? Like jobs wise and studying wise and everything.
Okay. Aerospace engineering, I believe, involve more towards the behavior of aircraft, or the behavior of aerospace, not aerospace, but the behavior of flying objects, fundamentally, right? So you are, I believe, you are studying thermodynamics and stuff like that, right? In your courses.
Yeah, aerodynamics.
Yeah, aerodynamics. So the aerospace engineering is trying to understand, one, the behavior of aircraft system. Secondly, is how the behavior is put into place. That is where the engineering parts come in. Aeronautical is more towards the theoretical concept of aerospace engineering, right?
So aeronautical is like the more general version of aerospace.
I
You
would
can
say
that
I
somehow.
would say the vice versa. Aerospace engineering would be more towards practicality of aeronautical engineering.
So aeronautical is more in detail?
Yes, they will be more towards conceptual and theoretical part of how aircraft works. Yeah, engineering, because like aerospace engineering will involve more on the the build up of the structure or the fabrication of the structure and how it works, stuff like that. But
Yeah.
aeronautical is heavily involved more towards the fundamentals things of
Yeah,
aircraft.
I get it. Thank you very much.
No problem.
Is there any questions? Maybe the last question for today. There's a question, Sekra. Mr. Ikrak, may I ask which programming language is the main advantages comparing to others while working for AI? Will you kindly mention the advantages as well, please?
Okay. I would actually advise you guys to go deeper into Python. And I believe you have a course in Python programming as well, right? Yeah, okay. So specifically for AI algorithm, Python will be one of the best because Python have a lot of libraries and modules that cater to those stuff. And if you guys are currently using graphic cards, Python have what we call back-end loader that can actually connect your graphic cards to train your machine learning models. So this is where you hear about all this TensorFlow, Keras and stuff like that. The second will be R, but R is heavily towards data science, projections of data, towards predictions of various data that you have basically. But if you want to go deep into Python, it's actually one of the best things for you to start. Best language for you to start. Yeah. No problem.
I think that's all for Q&A session. I would like to take this opportunity to thank Mr. Ikrak for spending his time to share his knowledge. Mr. Ikrak, before we end our talk today, is there any final advice or message that you would like to give us? If you have.
Okay, the first one will be pretty generic, but I think if you are trying to pursue a career in aerospace engineering, right? The one thing that I would advise you to do is to know your environment. Like I would say, based on my advice just now, know the scope of the things the aerospace industry are currently working on. That's one thing you need to do, right? Because not to be pessimistic, not all aerospace engineering student will end up in the aerospace industry, right? Like all other courses as well. Even mechanical engineering will end up in the aerospace industry, most of them. But if you really wanted to focus on aerospace engineering, you need to start to get to know the landscape of aerospace industry, especially in Malaysia, unless you have the opportunity to pursue your career overseas. Secondly, will be this is probably a bit more pragmatic lah. I'll come back to the skills that you can develop as a student. So don't just develop good grades, develop characters, right? Find the things that you like to do and do it. Because again, good grades is good, but when it comes to a real working life, a lot of other factors going to be taken into account whether you're going to be a good worker or even a bosses, right? So develop a good characters and understand that every people have their own quirks. And final one will be go back to FYP, right? Develop a very strong use cases for yourself so that you can stand out among other people. Don't be afraid to jump department if you think that it is worthwhile and if you think that it is feasible for you to develop. And yeah, make sure it is something that you like, you know, because if you don't like it, if you are doing just what your lecturer asks you to do or just what the lecturer are proposing you to do, you won't own it. So you won't feel proud doing it, sorry. So when later on in life, people are asking you, okay, what do you want to do? I don't know. So they don't want that. At least if I ask something, what you want to do, for certain, even though the fact that we're not hiring anything that regards to your field, at least for sure, we know that you are into something, right? So that could be a lifetime direction for you. It could be outside of aerospace as well. So don't be sad. The world is, you know, have a lot of potentials. Be open to it. Yeah.
Thank you again for answering those questions and for the great speech, Mr. Ikra. It was a pleasure to have you with us today. Okay, last but not the least, we are going to have our photo session. So technical team, please take a picture of us. Once you are ready, please tell 1, 2, 3. So that we won't be candid every time.
Yeah, someone can just share me this photo later. Yeah.
All right. Okay, boleh, Mr. Kok. All right, ready everyone? I will count to 3 and I will take a screenshot on the first page first, yeah? All right, 1, 2, 3. Okay, good. Right, for the second page. Okay, all right, I will count 1, 2, 3. All right, good. Okay, done.
Thank you so much, Hanan. Okay. All right, guys. On behalf of Aeros Club, thank you so much for listening to us, for staying with us tonight. Before you leave, please scan the QR code that will be displayed in just a few moments. And please fill in the attendance form, and you may leave once it's done. Thank you so much.
Mr. Krop. So yes. on behalf of Aeros Club and the students, I would like to say thank you very much for your willingness to deliver your speech for tonight. Actually, we have one of our lecturer over here. We have Dr. Sharil Azrat.
Okay. Good. Yeah. That's good. Probably I can contact you later on if you have projects with our company.
Yeah. Thanks. Yeah. Actually, I just heard that Dr. Chia. Are you working with Dr. Chia?
I'm sorry. Which is it? Oh. Is he from Aerospace Malaysia as well, or?
No. It's from he's from our department, Aerospace Engineering. He said that he received some invitation of some project with AMIC. So then today is the talk about artificial intelligence. So I wonder whether he is working with you.
I believe it's one of my colleagues because the way we work is every university is assigned with one staff or one researcher. So probably one of my colleagues there. Yeah.
Yeah. So he was sharing with me the details, and so maybe inshallah maybe we can collaborate later and
yeah.
we can meet. Yeah. Thanks a lot. Thanks a lot for the
forward to that.
Yeah. Thanks a lot for the speech today.
No problem. Okay, from my side, actually, I apologize a bit if the speech or the presentation is a bit too technical. This is actually the first time I actually presented to students, right? So before this is more towards engineers and technical stuff. And I hope whatever that I'm saying is actually could be beneficial for everyone here.
Of course.
Yeah, and I look forward to collaborate with UPM if there's a chance. Yeah.
Yeah. Inshallah, we have good projects in the pipeline.
Good. All right. Yes.
We connect it.
Yeah. Or you can just like email me. You know my email just now, right? Wait, let me share my screen. Can you just let me share my screens for once?
Oh, okay. Yeah, why not? And how about internship opportunities in EMIC?
That's a good point that you brought up. We're actually looking for interns. We're actively looking for interns. We have several projects coming our way. We need as much help as we could find. So if you have, you want to join us, you can just drop your resume or CV to me directly, and I'll just delegate it to the team. Yeah.
All right. Take note, guys.
Wait, can you see my screen already?
Yeah.
So yeah, you can just like push me to one of those emails. Yeah.
Okay, so Vishni, I think if there's no any agendas, I think we can put a wrap up for this event.
Yeah. So thank you, Mr. Ikrar. Thanks again.
No problem.
I think the talk was very beneficial to all of us, even though we are just first year students.
Okay. So if I think if everyone have fill in the attendance form, I think we can end the session. So again, on behalf of Aeros Club and on behalf of Aero Tech Talk Committee, I would like to say thank you to all of you for those who participating. Of course, especially to Dr. Syaril Azrat and of course, Mr. Ikrar Kamal for your willingness. And see you guys in the next event. We have a lot of list of events that we are going to have in future time. So thank you very much and good night, everyone. Thank you.
Thank you, guys. Good night.
Good night.
Thank you. Thank you very much.
Thank you.
Thank you, guys. Good night, everyone.
Thank you.